Within the retail investment sector, an algorithm error triggers immediate federal investigation and regulatory enforcement. Take the case of Maria, a retail investor. She submits an 18-word query regarding her $18,500 bonus. I want to invest this for a house in 8 years, but I can't lose more than 15%. The system has 30 seconds to translate that fuzzy human emotion into a mathematically sound, legally binding portfolio. While it's tempting to let a large language model generate the allocation directly, compliant architectures prohibit LLMs from creating the actual advice. The LLM serves exclusively as a semantic translator and supervisor. It orchestrates deterministic, math-heavy submodules that execute the core logic. This diagram positions the financial advisory agent within the 30-agent taxonomy, where it builds on the memory and orchestration primitives established in earlier chapters. In a market defined by strict suitability rules, deploying a raw generative model is a liability. Orchestration provides the only viable path to compliance. The core topology utilizes a central supervisor node to delegate tasks across 5 specialized subagents. The onboarding module begins the trace, pulling Maria's Know Your Customer profile from a semantic vector database. The system translates the phrase, "can't lose more than 15%, into a rigid 95% value at risk ceiling and a 14.9% maximum drawdown constraint. If the semantic translation is ambiguous, the confidence gate triggers. The agent halts to request human clarification, rather than risking an incorrect guess. Once the intent is quantified, the Market Intelligence module verifies all incoming data against a session-aware service-level agreement for Freshness. A scheduling ontology accounts for exchange hours and volatility. It identifies the difference between a standard Sunday closure and a 15-minute latency gap during a volatile session. The system compares timestamps across independent feeds. If the data becomes more than 15 minutes stale during active hours, the agent executes a hard halt. Acting on rotten data exposes the brokerage to massive FINRA liability. Maintaining data freshness is a requirement for survival in the retail advisory space. The execution trace now moves to the reason portfolio phase. Here, the system runs Markowitz mean variance optimization to balance risk against potential returns. To prevent hallucination, the architecture restricts the agent to a strictly versioned product universe protected by cryptographic hashes. The LLM cannot output standard ticker symbols. It must provide exact match hashes, such as VTI_V2025Q4. Any attempt to reference an undeclared ticker results in an immediate lookup failure. The token is rejected and construction aborts. The risk monitoring module then executes deterministic arithmetic outside of the LLM's reach, ensuring the final numbers are auditable. The agent subjects the portfolio to stress tests, simulating the 50% equity drawdown seen in the 2008 financial crisis. This leads to the central logic of the entire system, the compliance gate. In Maria's case, the new portfolio draft passes isolation checks, but fails a holistic scan of her existing holdings. The scan detects concentration creep. Maria's existing large-cap positions have appreciated so much that the new allocation would violate a strict 25% single asset limit. A human advisor might overlook a minor concentration flag. The AI, however, is physically incapable of skipping the gate. The compliance gate rejects the recommendation and sends a structured payload back to the reasoning phase for immediate revision. The agent employs a greedy constraint satisfaction algorithm, adjusting asset weights stepwise until every compliance score is mathematically cleared. If the system cannot find a compliant solution within 5 iterations, it exits with an advice unavailable message, rather than forcing a non-compliant fit. Every successful recommendation produces a time-stamped immutable audit receipt that cross-references the exact market data and constraints used. Beyond the code, this architecture responds to the economic realities of the modern wealth management industry. Currently, 65% of U.S. households sit below the $250,000 minimum required by most full-service wealth managers. Early robo-advisors tried to fill this gap, but they lacked the architectural depth required for complex, multivariable reasoning. Meanwhile, regulations like SEC Reg BI and MiFID II have turned suitability into a strict requirement that firms must be able to demonstrate at scale. The agent resolves international regulatory conflicts using the principle of lex superior, where the most restrictive rule takes precedence. Banks like JPMorgan and Morgan Stanley are deploying internal co-pilots for advisors, while digital-first platforms like Vanguard and Betterment scale hybrid automated models. By 2026, bespoke personalization is the baseline cost of entry dictated by global law. This timeline shows the shift from early AI experimentation in 2022 to the core agentic compliance pipelines used today. Regulators are now actively auditing firms for AI washing, requiring proof that algorithms genuinely prioritize the client's best interest. By bounding machine speed with an explainable gate, the system provides defensible advice in seconds. Next, we apply this same architecture to the legal intelligence agent. For the foundational code, consult 30 agents every AI engineer must build.